Hi guys, it's Dalton here from Comm Advantage. Today I want to talk about time value of money. This is a super fundamental concept for all of our finance courses, and it's something that we want to make sure that we understand thoroughly. So as we get into the course and things start going quickly, we are on our A game. So time value of money is really asking the question of, would we rather have $100 today or $100 a year from now? And the answer is we'd rather have it today. Why? Not just because we don't know if someone might pay us in the future, so give me my money now, but it's because we can put that money to work for us. We can invest it. If we have some money in our pocket today, theoretically, we can go out, we can invest it, and we're going to have more money a year from now. So let's take a look at that investment. So how much money would we have a year from now if the annual percentage rate, also known as APR, also known as market return or whatever we can invest our money for, is 6% compounded annually? What we're talking about here is taking money right now, year zero, putting it in the market, earning interest at 6% per year, and then looking at how much money we have a year from now. So if we were to invest $100, this $100 is called the present value. Present value, denoted as PV in our formulas, is us saying this is the dollar amount in today's dollars. What we want to find here is the future value. How much is this money going to be worth a year from now? And so in order to find this future value amount, we have a formula. This formula, our future value, is equal to our present value. And what we're doing is we're pulling that present value forward. So in this situation, that $100 that we have, if we're going to earn interest on it, we're going to multiply it by that 1.06, getting that 6% interest, and it's going to tell us that in the future, we would have $106 there. We can do this for more than one period, and this is where the formula comes into play. So our R here represents that interest rate, and T is our number of periods. So in this situation, it was just 1 year going forward. So really it's like there's a 1 there. But if I was going 3 or 4 years into the future, I would just put 3 or 4 in for that T value. It doesn't have to be annual. It could be monthly, weekly, daily, all kinds of different interest rates. But let's look at monthly compounding interest. So in this situation, what if we wanted to be compounding monthly instead of annually? So we're talking about a 6% per year. So that means that we're actually getting 0.5% per month, right? If we take that 6% per year and we divide by the fact that there's 12 months, we're going to get the fact that it's 0.5% per month, okay? Be careful with 0.5%. When we go to write that as our interest rate R as a decimal, lots of times, and sometimes we have this issue in statistics as well, we convert it and we write it as 0.05, but that is 5%. What we're really looking for there is that 0.5. So just watch that. And so the other thing we want to recognize is that we're discounting back 12 periods instead of 1 year. So if we're looking at this in our picture, it's not just us going from year 0 to year 1, it's us going from month 0 all the way up to month 12. So we're going to take that amount and we're going to apply that 0.5% interest rate each period. And so you're going to end up applying that 0.5% 12 times. So if we invest $100, what it's worth in month 1 is that $100 times the 1.005. But what it's worth in month 2 is that $100 1.005 to the 2 because we would have gone forward 2 periods. So if we're going all the way from our present value of $100 in the current period, whatever month this is, to that future value is happening in this case at t equals 12. So when we use our formula, sometimes when we look at this, we're like, whoa, it's a whole different formula, but it's really the same thing that we were just using. What it's doing here is it's taking that present value and multiplying it again by that interest rate. But what we have is we're taking that interest rate, that annual one that we were given, that 6%, and we're dividing it by the number of periods. So that's what M is. It's that number of periods per year. And so what we end up having here is us taking that $100, and the formula is actually finding that 0.5% for us, the one that we found in the slide before. And the number of periods that we're dealing with, well, we use our M times T. So that T being the number of years and M being the periods per year. The important takeaway here is that the number that we're using in our exponent is the total number of times we would have applied that interest rate. In this case, 12. So really that calculation simplifies down into us taking that present value of $100, applying our interest rate 12 times, and our interest rate being 0.5%. And so when we do that, we could take that $100 and go forward 1 month, the next month, then the next month, then the next month, and so on. But we can use our formula to come out with the fact that it's worth $106.17 a year from now. And what we take away here is that we just earn more money, even though it's 6% annually, because it was compounded monthly. So what's happening there is every one of these months, we're earning a little bit more interest, and then we're going to earn interest on that interest. So we like things that are compounded in smaller periods if we're investing ourselves. So in this case, it was worth $106.17 a year from now, whereas if we were just doing it annually, it was only worth $106. And so what this brings us to the idea of is the effective annual rate. So the effective annual rate, the EAR, is us talking about the interest rate, but it's the equivalent interest rate if compound interest was paid out only once annually. Versus the annual percentage rate, it ignores compounding. It's just telling us what that percentage rate is per year. And that's why we had to divide it out in order to do our calculation there. So this can be called the stated, quoted, nominal rate. It can be the market return. There's lots of different ways that it can be described. And lots of times we have to convert between the two of these. So to convert from our APR to our EAR, we have our formula here. And this actually looks a lot like the other formula that we are working with, just without the present value component of it. So it's 1 plus, we're taking that APR, whatever they give us, dividing by M. And so that M, again, is the number of periods per year. So if it was monthly, we're dealing with 12. If it was semi-annually, 2. If it's weekly, 52. And you're going to see that that M is also in the exponent there. So if we look at what we previously had here, right, this was our question we had before where we invested $100 and we got that 106.17. The question to ask here, okay, we know that the annual percentage rate is 6%, but what is the effective annual rate? What is it equivalent to if we only were paid out once annually? So our annual rate was 6% and it was being compounded monthly. So to find that effective annual rate, we're going 1 plus that 0.06 divided by 12, 12 in our exponent, and we would subtract 1 off there. And we're going to get our 0.0617. So what we're saying here is that if we invest that $100 into an account that pays you 6% compounded monthly, that's the exact same thing as putting it into an account that pays 6.17% annually. So we can also take a look at this graphically as well. So again, it means that if we've got that 6% compounded monthly, it's the same thing as an account that pays 6.17% annually. And so all we're really talking about here is that if it was compounded monthly, every month we're applying that interest rate, but if it's compounded annually, it's only being calculated once. But it gives us that same final value, okay? And so all we're saying here is that APR is 6%, and the EAR is 6.17%. So let's try a mini practice problem here. So we have two options. Under option A, we could receive $500 a year from now. Under option B, we would receive $200 today and $300 in 2 years' time. We have an annual interest rate of 5% compounded semi-annually. So this is telling us that our interest rate is 5%, but our number of periods per year, M, is going to be 2. And so the question is, well, which of these options do we prefer? So anytime we're comparing two different things like this, we always want to put it into today's dollars. So we want to find the present value. That's always going to be the goal, okay? We want to find the present value of both options. And what this will do is it'll allow us to kind of put things on a level playing field and really figure out what's most valuable to us. So if we think about what's going on here under option A, we are getting, if we start out kind of at period 0, we've got nothing, and then a year from now, we are getting $500. So this is the future value, and that's a year from now. But what we want to recognize is that because it's being compounded semi-annually, that's actually 2 periods from now. This is what's going on at year 1. And so we want to go backwards and we want to figure out, well, what is the present value? What is that worth in today's dollars? So anytime that we have a future value and we want to go backwards to a present value, we're going to divide by that discount factor. We want to go backwards in this situation. And so our present value is equal to whatever our future value is, divided by that 1 plus R over M to the T there. And remember, that R divided by M is really just us taking whatever that annual interest rate is and figuring out what's it worth for the single period, okay? So in this situation, that future value is $500, and our interest rate is that 5%. So we're gonna have 1 plus that 0.05. There's 2 periods per year. We have 2 periods per year, and we're doing this for 1 year. And remember, this actually simplifies down to the fact that it's 500, and we could think about the fact that it's just that interest rate of 0.25 for 2 periods. It's the same thing, however you want to think about it. So the value here, that present value, what that $500 is worth today, is going to be worth $475.91. So that is our baseline. And the question becomes then, does option B give us more money than that today? So let's take a look at option B there. So option B, we got a little bit more going on. Today, we get $200. But 2 years from now, we get $300. Remember though, that 2 years from now is really going to be 4 periods. Because we're compounding semi-annually, we always want to think about, how that money, how that interest is being applied there. So to figure out the present value, we have that $200, it's already in terms of the present value. But we do need to bring that $300 back and figure out what it's worth in today's dollars. So the present value of that $300, we're going to take that 300, the future value, and we're going to divide by, again, 1 plus whatever that annual interest rate is, so that 5%, divided by, well, how many periods are in a year in this problem? It's semi-annual, so it's 2. How many periods per year? 2. And how many years? 2. And remember, this is just us taking that future value and dividing by, in this case, 1.025, where it's 2.5% per period is getting applied in terms of interest there. And we're doing that for 4 periods. So the exponent in that denominator is 4. And so what it tells us is that the present value of that $300 is going to be $271.79. So that $300 is worth $271.79. So for option B, the present value is going to be, hey, that $200 that we get today and that $300, bringing it back into days terms. So in total, it's worth $471.79. And as we saw with option A was worth $475.91. So we're going to want to pick option A. It's worth more in today's dollars. Now, don't get me wrong, the problems that you're going to end up doing are going to be way fancier, way more interesting than this, but we need to have our foundations before we do any of those big fancy problems. Remember, if you've got any questions, please feel free to reach out by email or on social media. Happy to answer them, happy to get you set up for any help that you need. Reminder that we have finance tutoring, BDM tutoring. We have our weekly tutorials for both BDM and finance, and we've got our review sessions coming up for midterms and finals as well. Enjoy, guys.